open source distributed SQL database, and its main characteristics include that it's, first of all, it's a relational database, so we provide ACID transactions support, SQL dialect, our own extension for ANSI SQL, we call it YQL, yet another query language. It's strong, consistent database, so from CAP theorem point of view, it's CP. In case of partitioning, we tend to be consistent database. And we provide serializable transaction resolution level. We can scale up and scale down from few servers up to thousands of servers, and in production our main clusters consists of thousands of servers. Our biggest installation consists of more than 3,000 of servers. This is a highly available database, so we created it in order to run in multiple data centers, or we can call this available zones. It's fully automatic, so under one of availability zone or data center downtime, it survives and it continue be available for both reads and writes without any intervention. And after your data center is up, everything still working, and your programmers don't see any problems on their side. So the system is fully automatic. Okay, it's mission critical database, so it works in projects with 24/7 uptime requirements, and we provide rolling restarts and rolling upgrades, changing of hardware or everything without any downtime. And we created this not only as a relational database, but as a data platform, provided ability to create tables, persistent queue topics, distributed queries, and even analytics. It's 100% open source software, built from scratch almost 10 years ago, built on C++, and 1 year ago we published our source code under the Apache 2.0 license. The whole platform, SDKs, documentation, everything is available under Apache 2.0. Please join us on GitHub. You can see URL on the screen, or you can use the QR code. From physical architecture point of view, it's shard nothing architecture, and we tend to use only commodity hardware, so no any vendor lock-in on any storages or any computers. You can buy any available server, any available CPU, memory, etc., and build your own cluster. Compute and storage layers are separated into two parts, so you can easily grow and shrink every of them independently. For example, let's say you have millions of transactions per second and only megabytes of data, or you can have petabytes of data and single transactions per second, and you can grow each layer for your workload. Main primitive of the system, one of the main primitives is a table. Tables have primary keys and data within this primary key ordered, so you can easily make lookups to this table. And the main point is that you can grow up your data in the table almost infinitely, from kilobytes to petabytes, without any intervention from programmers or from your DBA, etc. Tables are automatically partitioned by primary key range. So we gather statistics about your workload, about your reads and writes, and depending on it, we can split it automatically. Based on statistics collected, we can split table by load, by your data amount, or by your read or write throughput. And system itself tends to put all those table shards through the whole nodes evenly by the whole cluster. Our dialect has some extensions to ANSI. It's strong typing with named subqueries. So we have a lot of built-in functions for any cases, like for datetime, math, JSON, Unicode, etc. And you can find very familiar constructions in DML and DDL, so everything will be very familiar for anyone. Main features of the system is secondary indexes. We have synchronous, asynchronous covering indexes. We have special time to leave indexes. Automatically deletes your data after it's expired. We have table compressions and backup and restore from S3. I will continue with the features. It's encryption at rest and in transit. We have read replicas in case you want to increase your read throughput. Special change data capture, you want to keep track of your data changes within the tables. Special JSON API with text JSON and binary JSON representation and functions to work with it. And special analytical scan queries in case you want to deal with your data without any problem with your OLTP workload simultaneously. From a programmer's point of view, our application team creates, as far as we have gRPC API, public gRPC API, our application team creates SDK for many for most popular languages. You can see them on the screen. In case you want to deal with a database in a convenient way, we provide user interface, included a lot of useful features like DB Navigator, like execution, explain plans, diagnostics, etc. And in case you want to deal with database through CLI or use it in, any scripting language, you can use our CLI that completely covers all our API functions. We provide a lot of functionality for observability of your database, and we support mostly popular Prometheus format. We provide in our GitHub a repository Grafana dashboards for database, and with every cluster, with every binary, we have embedded user interface and special system tables for a representation of statistics and analytics of your workloads. So you can observe your tables partitions, your queries like solo queries, heavy queries, etc. You can easily deploy YDB with our Kubernetes operator, or for example, use our Minikube for development and testing purposes. You can use it in virtual machines or just run it in bare metal using binaries or compile it yourself. Or at least use Docker container for development and testing purposes. And I'm almost done. And I just wanted to say that it's still work in progress. So it's quite a major product. We started our development almost 10 years ago, but we are on the way of continuous improvements. And as we saw a lot of our clients request to be more compatible with most popular databases, we work on PostgreSQL compatibility. So now currently we almost completed support of PostgreSQL dialect syntaxes. We completed support of PostgreSQL data types, almost all embedded functions via protocol, and we tend to be compatible with PostgreSQL. Moreover, we tend to be, and our aim is to be a so-called H-step system, so both system for simultaneously for OLTP workloads and analytical workloads without any intervention between them. So we work on our columnar store. So when I talked about tables, I talked about row-based store. So now we are in progress with columnar store for analytical tables. We work on data tiering. So we can cool down your data to most cheapest disks, like spinning ones, or you can cool down your data, your mostly like useless data to S3, for example. So it's one of the cheapest ways to store your data, and all the stuff will be invisible for end users. So you can have one table, and the table will store based on the tiering. It will stores all the data on different storages, but you can within the one query just make a query like select asterisk from table with any filters, etc. Moreover, we work on streaming analytics on those analytical tables, and that's it. Thank you again. Please join us on GitHub, visit our website. You can find there all documentation or materials. So we will be very grateful if you join our community. Thanks again. Thank you for having us.
So, do any of you have any questions?
Hi, so I just want to ask, right, so you have your own query language, YQL. So I understand that most other databases, when they have their own query language, is because they can't fully support SQL natively, like all types of queries. So is there anything that SQL can do, but YQL cannot?
We tend to be compatible with, as I mentioned before, we tend to be compatible with PostgreSQL, so we tend to cover almost all the SQL features. And we created it because it's a dialect both for our OLTP system and moreover for MapReduce system. So we try to cover the many stuff, not only for OLTP workloads, but for analytics, for MapReduce, etc.
I think, okay. Thank you. Do you have a feature like in your data capture that you mentioned to replicate to another database from YDB? Options for replication between different databases?
Yes, through CDC you can have all your data changes in topic, and you can read the topic and have all the data in different databases or wherever you want, in S3, in PostgreSQL, etc. Or in another YDB database on another YDB cluster.
One more quick question. Very quick. Less than okay, two quick questions. One of them is no benchmarks. Any benchmarks results you have against the other databases or some of the use cases? Maybe you can provide later. The other one is this used in production someplace? What are the examples?
Yes, we have a lot of examples. For example, you can find application or I'd say ecosystem like Grab, for example, with ride-hailing, ride-sharing, food delivery, etc. And this is perfect example. So we have the same one, running ecosystem that use YDB as its database for all those microservices, or for example marketplaces. And yes, about benchmarks, we're working on it. So it's still work in progress, but I hope that within the next couple of months we will be ready to publish our benchmarks with different distributed systems.
I think with that we can wind up. So thank you everyone. Thank you for all the wonderful questions you have asked. Okay. Thank you.